Hi everyone, we are group 16, and in this video I will walk you through my approach to building a high-performing R&B price predictor using machine learning. And this is part of the M3 Final Hackthon, and where our goal was to develop a regressor that minimizes RMSE and submit predictions up to Kaggle. And I'll explain the steps I took to pre-process the data, train the model, evaluate its performance, and ultimately generate predictions. To start with data exploration and feature engineering, we started by loading and exploring the Airbnb dataset to understand what feature might be useful for predicting price. And the dataset includes details such as location, availability, number of reviews, and more. And some columns like ID, name, host ID, and last review were removed because they don't contribute meaningful information to price prediction. And to improve our model performance, we created new features. First, we engineered host density, which calculates how many listings a host has in an area. This helps determine if a neighborhood is highly commercialized or dominated by individual hosts. And next, I'll introduce a demand score, which combines availability and reviews to estimate the popularity of a listing. And additionally, we transformed latitude and longitude into bins to better capture neighborhood level trends instead of treating them as continuous variables. And after feature engineering, we checked for missing values and duplicate entries to clean the data before training the model.
Once the data was cleaned, I prepared for training by applying different pre-processing techniques. Categorical features like neighborhood group and room type were encoded using one-hot encoding to convert them into numerical format. Numerical features were standardized using standard scalar, and missing values were imputed using simple imputer to ensure no gaps in the dataset. For the model, I initially used a random forest regressor, but I realized that training was very slow because the dataset was large. To optimize both training time and performance, I made several improvements. First, I sampled by only 30% of the data instead of using the full dataset to speed up processing. Second, I selected only the most important features based on correlation with price, reducing unnecessary calculations. Third, I adjusted hyperparameters such as setting an estimator to 50 instead of 200 and limiting max steps to 10, making the model train faster while still maintaining good accuracy. After implementing 3 optimizations, the model successfully completed training and I was able to evaluate its performance. Model evaluation and learning curve analysis we did to ensure the model wasn't overfitting or underfitting. I plotted a learning curve which allowed me to compare training errors versus validation error as the dataset size increased. A small gap between the two errors indicated that the model was generalizing well. Additionally, I performed cross-validation to confirm the RMSE was consistent across different training splits, which ensured that the model's performance was stable.
So during this process, we encountered a common issue where the test dataset contained features that were not present in the training dataset. This caused an error when making predictions. To fix this, we ensured that the test dataset contained only the same features as the training dataset, preventing any mismatch. The final step, making predictions and Kaggle submission. Once we had a well-trained model, we used it to make predictions on the test dataset. To match the structure of the training data, we dropped unnecessary columns and kept only the selected features. We then used the trained model to generate price prediction and save them in a submit CVS file This file was then uploaded to Kaggle to evaluate the model's performance on the leaderboard. And overall, this project gave us a hands-on experience with regression modeling, hyperparameter tuning, and debugging common machine learning issues. One of the biggest takeaways was the importance of feature selection and pre-processing. Simplifying the dataset significantly improved training efficiency without sacrificing accuracy. Another key learning was how to balance model performance with training speed by tuning hyperparameters and reducing data size. If we had more time, we would experiment with other models like XGBoost or LightGBM, which might further improve accuracy. And thank you for watching. I hope this walkthrough was helpful. If you have any questions, feel free to reach out.